Welcome to the second in our series of 3 videos, in which I'm going to go through step questions submitted by our viewers. In this video, we're going to look at some work which is very thorough and clear. There are 6 pages for just one question due to all the detailed written remarks explaining exactly what's going on. Unfortunately, this does run the risk of eating up more time than is necessary. So let's think about ways the work could have been made slightly more concise to get all the marks in a fraction of the time. So let me begin by saying I was impressed to receive a submission attempting this question in particular. It's not a particularly straightforward algebraic plug and chug. There's lots of logical subtlety, lots of wordy explanation needed. And before we get into the specifics, the student has done a really good job. And we'll see that's reflected in the final mark. Let's go through bit by bit. So first of all, the first 3 marks on the paper are G marks awarded for features of the graph. Now you'll notice that all 3 G marks are allocated to a very specific feature of the graph. It's not the case with graphs that the marker decides on a scale of 0 to 3 how good they think it is and awards a total sort of subjectively, but every mark has a very specific thing that it's allocated to. This can lead to some surprising peculiarities in marking, where, for example, a graph can look almost right, but get very little credit because certain key features are off, or can look completely wrong, but can get reasonably good partial credit if certain key features happen to be correct. Now, in this case, we've got a lovely big graph. I'm pleased to see that it's taking up half a page. I think that's a really good guideline to aim for. Half a page for a graph so that the examiner can clearly see the key features. And indeed, all the key features are clearly correct here. The first G mark is for the correct x-intercepts. Indeed, we have that. The second G mark is for the correct turning points. Indeed, we have that. And the third is for the quintic shape, which is negative between 0 and h and positive between h and c. And indeed, we have that too. So you'll see that still sticking with the graph rather, there is still one more mark to be awarded, an E mark, for justifying the location of the turning points and the x-intercept. So this is really important to note. Even though the question does not say to explain the features, unless the question uses the phrase state or write down or otherwise specifically says without workings, you should always assume that some justification is required. So that first E mark is for justifying the x-intercept at 0 and c and the turning points at a, b, and c. So luckily the student has indeed realized that we're going to need to justify this. So I can see that the turning points have been justified because they've pointed out that the roots of the original function f are turning points of big F because that's where we start to pick up a signed area of different size. So you'll notice that that's quite a lot wordier than what the mark scheme says, just area conditions give. Now, it's not a problem to say slightly more than the bare bones of the mark scheme, but I do think writing a full sentence here is a little bit overkill. For example, saying the original function f, we could have just said f, right? And that's just as precise. And, words like since, there's no need for connectives. We don't need to write full sentences in a formal, prosaic way. It's okay to use sort of abbreviations and so on. So, for instance, we could have communicated exactly the same point by just writing roots of f and then a double-headed arrow to show kind of correspondent TPs of big F. So that there contains exactly the same substance as what's been written here, but in a fraction of the time to write. So I know, this particular sentence, that's not a big time saving, but added up over the totality of the exam, getting into the spirit of writing abbreviations and sort of incomplete sentences rather than sort of essay-style full sentences can really save a lot of time. I do like, though, how we have this sort of bullet point format. It's very clear how the argument runs linearly. It's easier to disentangle what's going on. So in any case, I'm very happy that the turning points have been justified, and also that f of 0 and f of c are both 0 because, in that case, we have no integral at all. And in this case, positive and negative areas cancel. So that's really what they mean by the area conditions give. Again, we could have been slightly more concise here. So we could have just said f of 0 is 0 as no area, and f of c equals 0 as areas cancel. So that contains the same substance as what's been written here. The golden rule is that we're going for clarity so that everything is clear and explicit, but not necessarily formality on step. Nonetheless, I'm satisfied that the x-intercepts and turning points are justified, so that E mark is definitely received. Now, the next mark is an E mark, and it involves actually several things. So you will sometimes see in the exam that one mark will encompass doing several things at once, and you will need to do all of them to get the credit. So one thing encompassed by this E mark is justifying the x to the 5 coefficient. So I'm certainly happy with the justification here, but I think this argument is a little bit overkill. For example, there's no need to write hence if we integrate term by term. Integration is always done term by term, so we could have just done the integration. Moreover, it's a little bit unnecessary to write all the later coefficients as well. We could have just said that the x to the 5 coefficient comes from integrating 1 x to the 4, integral x to the 4 is a fifth x to the 5, and then just a ... just to remind the reader that there are more terms to come. So, this isn't a huge inefficiency, including the extra terms, but definitely things like hence if we integrate term by term, and the coefficient of x to the 4 in fx is, we could have just said x to the 4 coef is 1. So there's no need to write quite as wordy explanations. In any case, I'm certainly happy that that coefficient is justified. Now, we also, as part of the logic here, need to justify why it is that there are double roots at x equals 0 and x equals c. So in particular, in the form we're trying to justify, although the factor theorem tells us there should be a factor of x and a factor of x minus c, the fact that they are also turning points means they're double roots. We're touching and not cutting the x-axis, and the fact that they are touching points and therefore double roots is what justifies them having a second power. I mean, in fact, it means they have to have an even power, but a power higher than 2 would clearly be impossible. So I'm not really convinced here that there has been a sufficient justification of the reason why x squared and x minus c squared are appearing to a second power. When you're justifying something, it's so important to make sure you're really cutting to the heart of what's actually fundamental in the thing you're explaining. So yes, there is the fifth out front, which I'm satisfied by. Yes, there are the factors which are present, like the fact there is an h is nicely justified here. But I don't think the fact of those factors being squared is really justified adequately. And so unfortunately, we're going to lose that E mark. I do think it's rather harsh that there's only one mark for all of those things, but that's just the way it is with this question. So the subsequent bit of working is just verifying something about f of x plus f of c minus x. That's done very nicely here. I suppose the only thing I would say is maybe it wasn't necessary to do f of c minus x first. It would have been enough to just in one line write f of x and f of c minus x and then simplify. That being said, sometimes doing a kind of warm-up calculation can help to avoid a mess later on. So I don't really have much issue with this. Definitely the M and A mark are received here. Okay, so a very strong start on part 1, only 1 mark lost, and really just lost due to a very strict thing about the mark scheme. Let's now move to part 2. So in part 2, we're trying to deduce some inequalities and so on. Now, this is a little bit unnecessary. If I'm reading a mathematics research paper, yes, I would like to see things like let us consider only, let us, things like this, nice prosaic writing. But it's unnecessary in an exam where we're just going for bare bones clarity. We could just write 0c dot dot if we really want to make it clear that we're considering that interval. Even that is not really necessary, since the whole point of part 2, which we're now beginning, is actually all about that interval. So it's obvious enough that we're considering that regardless. So again, a little bit wordier than we need. Likewise here, the minimum point of, the maximum point of, we could have just said min at y equals k when x is b, or even max at bk, min at a minus k, for example. So it's not really necessary, again, to have these full sentences. We could have been a bit more concise. However, I'm very satisfied with the logic here. So the first D mark is just for justifying where the max and min are, both the value they attain and the value they are attained at. The student here calls it K. Doesn't matter. You can call it K or big A. Makes no difference. So we get that first mark. The next D mark is for justifying that f of x is always at least that value, with equality only at a specific case, which is at x equals a. So they've said that we have the or equal to, and they've justified that because x is actually not equal to a, because we're excluding that value, we can actually make the inequality strict. So definitely that second D mark is received. Now the B mark, that's an independent mark, is for considering a slightly different inequality. The student has done some other working first, which is more natural really in the narrative of the question. So we'll come back to that. What the student is doing is looking at f of b plus f of c minus b in order to try and deduce the possibilities. So I like the fact that they've said using part I here. The only thing I'm maybe slightly skeptical of is we could have been more precise about how we're using part I. So we could have said using part I with, because part I was for f of x plus f of c minus x, so we're using part I with the choice x equals c. And then when the student subsequently says using x equals c minus b, they're not talking about the x in part I, but they're using this in the last part. In other words, in this result. So it would have been nice to be slightly more precise about which results are being used and how, but certainly I'm satisfied. So they've used that result, knowing that this thing has to be positive by the last part. We have an expression for it, and we deduce that in order for that to be positive, I need this thing to be positive. Or in the case that x is actually equal to a, they're saying that we could have c minus b is equal to a. And that's just because this result here is dependent on the x, so to speak, not being a, which it was in that case. So the M mark and A mark are for deducing that we have c minus b is a, or c is less than 2h. I am satisfied with this. I think this is fine. The mark scheme says or c equals 2h and c minus b equals a. I'm going to use my discretion here and award the A mark anyway, because the question didn't actually say that you had to have c was 2h, and the student actually later on will engage with the fact that c is going to be 2h. Maybe not perfectly, but they will link to it. So I think that's fine. They have convincingly reasoned what was actually shown. The c equals 2h is just an extra thing you can note. Okay, so we then also need to try and prove by considering f of a plus f of x that c is a plus b and c is equal to 2h. So that's another reason why I'm not threatening that A mark there, because actually there's going to be another A mark later, or E mark, for the specific matter of c being 2h. So we then do exactly the same logic for f of a plus x. So that's actually what that B mark is for. Really here, we could have been a bit more concise. We could have just said, by logic as before, fa plus fx less than or equal to 0 with equality if and only if x is b, just like what they've written there. The logic is essentially the same, just with the inequality going the other way. So to write the same thing out with basically a swapped for b and the inequalities revert is a little bit overkill. we could have gotten that mark more easily. Or at the very least, we could have just kept it slightly more concise in the way that we discussed for the last part. But certainly I'm satisfied that here that B mark has been met. We then use the same logic. So I have the same gripe here. We could have been clearer what the X was in part I, and also that this was really being used in the inequality that we've just established. But we have the same logic. This thing has to be negative. So in order for it to be negative, we either need that X is less than 2H, or we need the loophole, which is that the X in this language is B, which means that C minus B is equal to A. So I'm happy that we can award the second M and A for the workings there. Now, the final E mark is for reasoning that, in fact, we must have the C being A plus B and C being 2H case and not the alternative. I am not quite convinced by this reasoning here, because the student says we've proven that C is bigger than 2H or C is smaller than 2H and C is smaller than 2H. I don't think we have actually proven that. What we've proven is that this or something else is true, and this or something else is true. In principle, we could have had that both of the results we've just established are true by virtue of C minus B being A. And I'm not quite convinced that the justification has been given for why this comes along with C equals 2H. We have a statement, hence it's false and so on. But this is one of the cases we could have had that instead. So I feel the logic has been a little bit muddled here. What I would like to have seen explained is that for each of the two claims, I have C bigger than 2H or C smaller than 2H, or the alternative. And it must be the alternative for at least one of them, because C bigger than 2H and C smaller than 2H are actually contradictory. Therefore, I've got C minus B is A, and then crucially, that means that I must have the equality case here, therefore that bracket vanishing. So I'm not convinced that that logic is really communicated here. I think we'll lose that final E mark. But generally, this is very good. Then we come to part 3. So in part 3, the first M and A mark are just for computing a formula for F. So how have we done that? We've plugged in what we know about C, we've expanded big F, and then we subsequently differentiate it. So this is completely fine. We get that M and that A. And moreover, the student has rightly noted that A and B are the roots of this. Okay, so in the question, we subsequently need to investigate the inflection points. Very sensibly, the student has then taken more derivatives to investigate the inflection points of F double prime. So they've computed that second derivative correctly. That's the second M and A mark. And then they have correctly noted that the inflection points must solve the same quadratic as the x-intercept. So we get that E mark as well. So I like this sort of annotation with an arrow showing that you don't need to write, again, in words, the quadratic must be solved by, but we just use a nice arrow to communicate slightly more concisely what our point is. I mean, we could have been even more concise. We could have said A and B must solve, but using an arrow to point at something is easier than writing everything in full sentences. So that's full marks on part 3. Overall, we've only dropped 2 marks and we get a very high score of 18 out of 20. Very comfortably on track for the very highest result in the exam. My only concern is whether in places we could have been a little bit briefer in our explanations, using abbreviations and shorthand rather than so many full sentences. Overall, there's not much to fault. An examiner would be delighted if this solution came across their desk, because the detail makes it easy to mark. There's no ambiguity in whether the marks are allowed to be awarded, and it's very unlikely that a marking error would occur, since everything's set out so clearly. The only danger is in running out of time. Remember that ideally you want to be getting through a step question in about 30 minutes. So you don't need to be writing full sentences. It's okay to use abbreviations, shorthand, and incomplete sentences in order to convey your argument. The emphasis should be on clarity, not rigor. Next time, we'll look at another solution, which I feel strikes a really good balance between writing enough to easily access all the marks whilst avoiding overly verbose explanations. Do remember to subscribe, and I'll look forward to seeing you next time.